Alright, so today we began with you guys using some markers, and you built this and you used a model to flip this triangle upside down. And what you did is you moved the top one to the bottom, and then these two side ones to this row, and then you have 4, 3, 2, 1, and it looks like this. And we discussed why it's so much easier to use a model in this rather than a drawing. You don't have to keep erasing and drawing and erasing and drawing. All right, we checked your homework next. And then today's really the last day, the last lesson of Chapter 2. So the big idea today was just about the graphs of inequalities. Sounds like something hard, but all they are number lines. And the solution is either an open or closed circle and shading. So we did these and you guys look for a pattern. So this says all of the numbers that are greater than 5, and there are infinite numbers greater than 5. So you start with your number line, and we put 5 in the middle, and one bigger than 5 to the right, and one smaller than 5 to the left. And because we can't include 5, but we need to include numbers like 5.01 and 5.001, so the way we deal with that on the number line is we make an open circle and we shade everything to the right, including the arrow, because remember there are infinite numbers that are bigger than 5. And then to show our check, we take one of the numbers in the shaded part and we put it in for x, and 6 is greater than 5, so we know we shaded the correct side. Okay, the second one was we're looking for all the numbers that are less than or equal to -4. So on our number line we put -4 first. One smaller than -4 is -5, and one bigger than -4 is -3. Remember, as you move to the right on a number line, numbers get bigger. So we'd get -2, -1, 0, and 0 is bigger than all these negative numbers. And then because the number can equal -4, we have a solid closed circle, and we shade to the left because we want all the numbers that are smaller than -4 or equal to -4. And I can pick -5 and substitute it to test to see if I shaded the correct side. -5 is less than -4, so I know I'm correct. Y is greater than or equal to 2. Solid circle on 2. And I shade to the right because I'm looking for all the answers that are bigger than or equal to 2. If I test 3, 3 is greater than 2, so I know I'm correct. Okay, then you practice some in your table group. So these are all the numbers that are greater than -4. So hollow circle on 4 and shaded to the right. All the numbers that are less than or equal to 12, solid circle on 12, shade to the left. And then y is greater than 3.5. Some of you counted by tenths and you put 3.5. 3.6 to the right, 3.4 to the left. Some of you counted by whole numbers, by halves rather, and you put 4 to the right and 3 to the left. And some of you counted by ones and had 4.5 to the right and 2.5 to the left. As long as these gaps represent the same amount, it's okay. So on this one we counted by tenths. The red ones are counting by halves, and the blue ones are counting by one whole. So we have a solid circle on 3.5, and we shade to the right. And if we test 4, 4 is greater than 3.5. If we test 3.6, it's greater than 3.5. And we test 4.5, it's greater than 3.5. So we know we shaded the correct side of the circle. Double inequalities are when you want to show a range of numbers. So I was telling you that in Vienna I've noticed that in residential areas where there are houses and apartments, the speed limit ranges from 30 kilometers an hour to 50 kilometers an hour. So we want to show your speed s can range for any number from 30 to 50. So I think I want to put these numbers in the same order they'd be on the number line. 30 is the smallest, my speed s goes in the middle, and 50 is the biggest. And the way you read this is 30 is less than or equal to s, which is less than or equal to 50. And on my number line, because I can drive 30 and I can drive 50, they're solid circles, and I shade everything in between. And if I test 40, 30 is less than 40, which is less than 50, so I know I shaded the correct part. And then I had you try one with your table group. So your age A can be any number from 10 to 15 to be in middle school. And I think every table group did it correctly. So you guys put 10 first because that's the smallest on the number line, and as we go to the right we get bigger. The age is between 10 and 15, and it can also equal 10 or 15. So we have a solid circle on 10, solid circle on 15, and everything between is shaded. And notice here I want to count by ones, so I can see 10, 11, 12, 13, 14, 15. I can substitute any of these numbers for A and I get a true statement. 10 is less than 11, which is less than 15. 10 is less than 12, which is less than 15, etc. And then you just practice some more at your table group. And this time we went the other way. I showed you the graph and you had to write the inequality. So all of these numbers right here, -4 is less than all those numbers, and all those numbers are less than or equal to 5. Solid circle here because less than or equal to, hollow circle here because it's just less than. So I can count any of these numbers here like 3.99, 3.98. So I have a hollow circle on -4 and shaded to the right until a solid circle on 5. And then you try these yourself. So all the numbers greater than or equal to -7, solid circle, shade to the right. All the numbers less than 1.5, hollow circle, shade to the left. All the solutions greater than 8 7/10, so hollow circle, shade to the right. Notice they counted by 1/10. And all of the numbers less than or equal to -5.5, so solid circle and shade to the left. And to have optimal health, an adult should consume between 1,800 and 2,500 calories per day. So the way that you write and graph that double inequality is if I say between, that does not include 1,800 or 2,500. So 1,800 is less than the number of calories per day, which is less than 2,500. Hollow circle on 1,800, hollow circle on 2,500, and shade in between. And then you have some homework to practice. And now if you've decided to do optimal health as your project, you have had every lesson you need to do that project now. So have a go.